Hi, good morning, everyone. My name is Amy Woodbury, and I'm with the Pacific Northwest National Laboratory, and I'd like to welcome you to the webinar, our Marine Renewable Energy Environmental Regulatory Workshop Report, Moving to Better Information and Risk Retirement. With that, I'd like to turn this over to Jason Bush, who is the Executive Director of POET, and he'll make some introductions.
All right, well, thank you for joining us today, and I'd like to take just a couple of minutes for some background and context. And I'd like to start by reminding you that for many in the marine renewable sector, like myself, the primary goal is to develop new forms of renewable energy to replace thermal energy resources that contribute to climate change. The sooner we develop alternatives, the sooner we can take existing thermal offline and stop investing in the infrastructure that perpetuates that system. Unfortunately, it's a truism in the marine renewable sector that these new technologies will not achieve maximum penetration in the U.S. sector if it continues to take 5 years or more to get the first small-scale grid-connected projects in the water, of which there will need to be many before we will actually be able to develop utility-scale projects. So one of the ways to shorten the permitting time and reduce the multi-million-dollar cost of that process is to ask and answer key environmental questions. And that is exactly what has been happening in several different countries around the world by agencies, by laboratories, universities, industry partners, and many others. People like Drs. Andrea Copping and Sharon Kramer, both of whom have been investigating and answering these key environmental questions related to marine renewables for several years. I don't know of any other two people so well qualified to discuss these topics, so I'm pleased that they have agreed to work with the Pacific Ocean Energy Trust on this effort. Speaking of POET, the Pacific Ocean Energy Trust, I'd like to briefly introduce this new group. Some of you are probably well aware that the Oregon Wave Energy Trust has been active in this space for many years. In fact, we'll be hosting our 12th annual Ocean Renewable Energy Conference coming up in Portland here in Oregon in September, on September 13th and 14th. But POET grows out of OWET. It is essentially OWET with longer legs, embracing all forms of offshore renewable energy, including floating wind, and we hope to work for the entire West Coast as a region. It's still a nascent organization, and we're trying to get some traction, but most of the work that OWET has historically done will now be done by Pacific Ocean Energy Trust POET. Work like the present effort, which I refer to as the dashboards, which you'll see why here in a few moments. So the Pacific Ocean Energy Trust is committed to shining light on the environmental issues in the hope that some of these key questions can be answered, and we can retire some of the risk associated with permitting of the projects, thus facilitating and expediting the adoption of non-thermal energy resources to power humanity's future. So with that, I'd like to thank, first of all, Matt Sanders, Program Manager for the Pacific Ocean Energy Trust and OWET, for bringing this effort together, along with Drs. Sharon Kramer and Andrea Copping and her excellent team at PNNL who helped to bring this webinar together. And with that, I'll turn it over to Andrea and Sharon. Thank you very much.
Thanks very much, Jason. This is Andrea Copping with Pacific Northwest National Laboratory, and my colleague Sharon Kramer with H.T. Harvey & Associates. With my colleague Sharon Kramer, we will sort of tag team on this presentation. Just to get started, next slide, please. I just want to give you a little background on the sort of purpose and need why we are giving this webinar today and the workshop it grew out of. As Jason has very eloquently said, the industry, marine renewables industry, is concerned that permitting processes have been very long, expensive. They've taken a lot of time. It's been very hard to get devices in the water. At the same time, the regulatory community is concerned about risk associated with key interactions of these devices, single devices and arrays, with protected marine animals, habitats, ecosystem processes. And both of these very legitimate concerns have really been at the intersection of what OWET and POET have done, trying to bring these groups together. In response to this need, OWET, POET held a workshop in association with their conference last fall on the 21st of September in Portland, Oregon. And Sharon and I were lucky enough to be asked to run that workshop. And that's a lot of what we're going to report on to you today. Next slide, please. The approach that we took was really to try to lay out the most recent research findings and ensure that there's open lines of communication throughout the community, regulators, developers, research community, to really move forward on environmental effects. So what we're going to do is start by giving you an overview of two of the recent, we think, very robust reporting on the state of environmental effects. The first is the 2016 Annex 4 State of the Science report that I will talk about, and then Sharon will cover the report that was done last year reporting on the 2015 workshop led by Department of Energy that Sharon had involvement in. Following that, we are going to present our approach, we call our dashboard approach, as Jason said, and we will give you a quick glance of what went on at the workshop. We had panels of industry or applicants discussing these dashboards and the state of where we are with permitting, and also had a panel of regulators. Then we'll finish up with some next steps. Next slide, please. So I'm going to get started and just give you a quick once-over on the State of the Science report. This was written by my organization and a lot of colleagues. Next slide, please. The purpose of it is to summarize the interactions and effects of the marine renewable energy devices on the marine environment, the animals they support, and the habitats. And the purpose of the State of the Science is really to be available to inform regulators and researchers about what potential risks there are from tidal and wave installations. And we believe this also has the ability to assist device developers so that when they look at the engineering, how they site, the operational strategies, maintenance strategies, they can really seek to minimize environmental effects right up front. And by this means both shorten permitting processes, but hopefully decrease the monitoring load that will have to happen post-installation. So the State of the Science report consists of 10 chapters. There were 13 authors from 6 countries. This is a collaborative effort under the Ocean Energy Systems, one of the IEA Technology Network partners. Next slide, please. So I'm going to just walk you through this State of the Science report at a very high level. It is a 250-page document, so not getting into great detail. The introductory chapter, of course, just sort of sets the stage, and one of the things we did was really try to talk about the benefits of marine renewable energy. We always talk in the environmental field about the risks, but we do need to keep front and center why we're doing that, what the benefits are. Next slide, please. The second chapter tried to really bring together an assessment of all the risks associated with these devices. Next slide. And what we found in looking broadly across the board at what had been done in this country and elsewhere is that the perceived level of risk is often driven by scientific uncertainty. We just don't have enough understanding of some of these interactions. And so many regulators, stakeholders, and others tend to err on the very conservative side and say, well, these are the bad things that can happen. But the good news about this is if we are able to collect more very direct and appropriate data and do the right kind of research, we can help to reduce this uncertainty, and therefore we believe the risk. What we see is the highest risk interactions continue to be potential collision of animals with turbines, obviously tidal river, not wave, underwater noise generated from both turbines and wave energy converters, the effect they may have on animals, and the concerns about electromagnetic fields from cables and energized devices. And to sort of give the bottom line up front, we generally believe from evidence to date around the world that very little impact can be expected from single devices deployed in the ocean. As we get to much larger arrays, we probably will have to continue to look at these and see if there are differences. Next slide, please. So collision risk, as I mentioned, is the tip of the problem for tidal turbines as far as really understanding what's going on. Next slide, please. And the animals that are potentially considered at risk are the marine mammals, fish, and diving seabirds. It's kind of funny because this being an international document, there are differences in countries. Everybody puts marine mammals at the top of their list. In the US and Canada, we tend to put fish next. In the UK and parts of Europe, diving birds come up next. So it's where you're sitting. Part of the reason why understanding marine mammal collision of animals is that, first of all, there's never been an observation of a marine mammal colliding with a turbine. We've seen fish interact pretty closely with turbines, but with no apparent negative outcomes. And the technologies that we need to observe these collisions are not well developed, and they're very tough parts of the ocean to work in. These are very high energy. As an oceanographer, I try to stay out of areas like this. So the problem is we know less about these high energy areas than other parts of the ocean. So in lieu of being able to necessarily view or observe these likely very rare events, there have been efforts to quantify the number of animals likely to be in the vicinity of a turbine and therefore at risk. And this is being done to try to, sort of understand what may happen. Unfortunately, these sort of models don't take into account the animal's behavior, their ability to sense and evade a turbine sort of at the last moment. But it's also important to note that most of this kind of modeling and observational work is done for individual animals who might interact with a turbine. But what we really care about is effects on populations, and we don't have very good ways of even moving from the individual to the population. Next slide, please. So the next issue that really comes up pretty high is this risk to marine animals from underwater sound. Next slide, please. And the reason we worry about this, as many of you may know, marine animals use underwater sound much as terrestrial animals use light or sight. So it's important that more sound in the ocean can interfere with communication, navigation of these animals. There are many other anthropogenic noises in the ocean, of course, and this could just add to further disturbance. Now, we've gotten quite good at knowing how to measure the noise from a single turbine or WEC, and we can then model. We have good acoustic propagation models to understand what an array would sound like. What we don't know is how animals are likely to behave around this. What is their response? Will they stay away? Will they be attracted? Will this interfere, etc.? So that's really the missing link there. Next slide, please. The next issue that we took on in the State of the Science was changes in physical systems. Next slide, please. As soon as you put a device in the water, you change the flow, or with a WEC, you may change the amount of energy in the waves. And the concern here is that at sort of the far end of putting a lot of these devices in the water, you might actually change ecosystem processes like water quality, oxygen, nutrient delivery, and also sediment transport. Now, this is a place where numerical models really helps us, because the changes that we know will occur from a single device are not measurable in the ocean against the level of background natural variability. But models allow us to put simulated turbines or WECs into very realistic water bodies and really understand what these changes in flow and energy removal will be. And the bottom line is we will not see a change from single devices, and what we need to do with these models in most well-sited water bodies is put many devices, hundreds to thousands in, before we start to see ecosystem changes of the sort we're concerned about. And of course, there's reasons why no one would let you put that many turbines in the water well beyond this. So we don't see this as a great risk. Next slide, please. Effects of electromagnetic fields on animals. Next slide, please. The concern here is that we will get EMF, electromagnetic fields emitted from export cables and also energized parts of devices. Now, the Earth has its own magnetic field, and we know and believe that many types of animals have some interaction with this magnetic field. We know of salmon and turtles, we believe, navigate by them. We also know there are other animals that have great sensitivity. Now, it's important to note that an animal cannot be affected by EMF unless it has the appropriate electro or magnetosensors. And we know some animals do for sure. Elasmobranchs, certain species of elasmobranchs, that's sharks, skates, and rays, and certain invertebrates, crab, lobster, are able to detect, and we can experimentally show they detect it. Now, it's also important to note that if power cables are buried, we physically separate the animals from the field and probably can take care of a good deal of that. There have been a number of studies, lab and field studies, that really look at both what the emissions are from cables, devices, and also what the likely effect on animals will be. And at the levels we see, we believe it is not likely that there will be effects on animals based on these levels of emissions. It's important to note that we did a lot of this in our own laboratory. If you put animals in proximity to these fields, they will note them. But in many cases, we had crab and lobster in the lab that were quite, perked up at the fields the first day, and by the second day, we're just going about their business. So we don't think this is largely a great concern, but it's probably not one that has completely been retired. Next slide, please. Changes in habitats caused by marine renewable energy that includes things like creating artificial reefs. Next slide, please. We know that as soon as you put a device in the water or put anchors in the bottom, you change some small piece of habitat. Now, if the devices are properly sited, they will be in areas where there's a great deal of similar habitat, provided you don't put a tidal turbine or WEC down on the one very precious reef in an area. You're probably not dealing with a great deal of habitat loss. Similarly, we know that as soon as you put devices or anything, structure in the ocean, that many types of fish and invertebrates will be attracted to that structure. And in fact, they may start to use that as new habitat if there's some nice structure that they like. But learning from other industries where we've been putting things in the ocean for a very long time, there really is no evidence to date that shows there's any harm. There's really not a mechanism of harm to these animals that we can show, or to loss of habitat, provided siting is done carefully. So we don't see this as a great risk. Next slide, please. Now, there's 3 more chapters in the state of the science that aren't really quite the same thing. They're not associated with a particular stressor affecting the marine environment. But our colleague Anne-Marie O'Hagan out of Ireland has written a chapter on marine spatial planning and marine renewable energy. Next slide, please. Many of you may be aware of marine spatial planning as a method of planning and managing uses of the ocean and the users that support sustainable development and really allow for coexistence of many industries, many uses from security, commercial fishing, recreation, etc. What Anne-Marie did was look across the Annex 4 countries at how marine spatial planning and marine renewable energy are used, and what we found was a real range of use of formal marine spatial planning processes, others where the principles of MSP are found in coastal management plans, and then others that aren't using marine spatial planning at all. And the conclusion from this is that that if you do have a good, stable planning system that's very transparent to stakeholders, you've got a very good chance of having this coexistence among these many different industries and really using and protecting the ocean at the same time. Next slide, please. Other colleagues from Portugal and Spain, Teresa Semas and Juan Bald, looked at case studies where devices or sites had been permitted and to see what we could learn from them. Next slide, please. They looked at 4 specific studies: a wave device that had been installed off Portugal for a period of time, the ORPC TideGen system in Cobscook Bay in Maine. They looked at the CGen, the marine current turbine technology in Strangford Lough in Northern Ireland. We all know that one, the big red iconic tower. And the 4th was BMAP, which is actually not a device, but rather a test site that has been fully permitted in the Basque Country of Spain. And this chapter's got a lot of richness to it, but I think the quick bottom lines are that if you carry out a strong stakeholder outreach process throughout the whole permitting and post-installation installation process, it really benefits your project moving forward and being permitted in a timely fashion. Similarly, having really robust monitoring plans, adaptive management strategies, and writing good environmental impact assessments makes a big difference. Again, it's not just going through the motions. It really can make a difference. We also found that there's no dedicated policies that streamline developments of wave and tidal devices in any countries around the world, which was interesting. It shows how young this industry really is. Next slide, please. The final chapter really tried to summarize what the previous chapters had said and look at a path forward. Next slide, please. And the approach we tried to take, I've said this term retire risk several times. I do want to note that something retires, it doesn't die. We're trying to really sort through what the highest potential risks are so that that's where the attention can be paid. And we do believe this uncertainty is really driving a great deal of this perception of risk. So if we start over on the left-hand pie chart there that says present situation, the large ochre piece is where we are right now with a lot of uncertain risks, and that represents how much monitoring is being done both pre and post installation. The little skinny green slice indicates those kinds of interactions we don't think are important or causing harm at this point and can be put aside, whereas the red slice indicates those that we know where harm is likely and there is mitigation or some kind of change needed. It is our hope moving to that right-hand pie chart by very well hypothesis-driven research and data collection, we can go to this preferred future where there is a much larger slice of this green retired risks. Those risks we understand. We do not need to go on monitoring on an ongoing basis. We always will have a slice of the red where there is need to mitigate, to make changes all the way from design through operations, maintenance, etc. And there we have considerably reduced the size of those really uncertain risks for which monitoring really needs to be concentrated. And we think this sort of scheme can benefit all members of the community. It will reduce monitoring burdens that are really making it difficult for developers to get anything in the water. It will help the regulators to know they are concentrating available resources on the most important unknown risks, and it will allow us to move forward. So that's it, and I'm going to turn it over to Sharon now to talk about the regulatory workshop.
So thank you. It just dawned on me hearing Andrea give her overview of the State of the Science report, which has been really instrumental in helping, I think, our understanding of the situation with respect to how the stressors interact with receptors. But that effort was kind of ongoing when this effort that I'm going to talk about, which was a workshop that was held 2 years ago in D.C., there's overlap. There is overlap, and I think that's good because I think we're coming to similar conclusions, if not the same conclusions, through slightly different approaches. So the regulators workshop, the title, the front page of the reports there was basically led by DOE and NREL with Ian Baring-Gould, Corey Crystal, and Al Levesque, myself, and Anna West from Kearns and West. And so the idea of this workshop was to bring together experts in various of the stressor-related environmental effects areas to discuss the current state of the science and what they've observed, and where there were still some concerns or where there were uncertainties with respect to MHK deployments. And the idea was that we were, that NREL, we invited a large group of MHK stakeholders, and again, these were not just, we had MHK applicants and developers there, but also we had federal and state representatives attending. The idea being to look at what we know, what we don't know, and where the monitoring and measurement of impacts was going. And we did also in this workshop share perspectives from both the development side and the regulatory side. So there's this workshop was really kind of held to start the dialogue between parties, if you will, between the regulatory side and the applicant side about what was working and what was not. Can we move to the next slide, please? So our perspective was a little different, similar but not exactly the same, in that we kind of looked at this known knowns, known unknowns, and unknown unknowns. This will sound familiar to some of you, where we looked at what we called known knowns, where we thought the issues were pretty well understood, and that monitoring was really not necessary or warranted. So these are well understood, some of those well understood issues that Andrea was talking about just beforehand. The known unknowns were ones where we had some uncertainty. We certainly have the technology and we have the ability to study them, but there were issues with respect to cost and whether or not the impacts were significant. So that was another bin. And then the third bin was what we called unknown unknowns, and these are areas that we have not assessed very well. We may not even, or may not be sure entirely we need to study these issues. And also importantly, maybe, does the technology even exist to be able to evaluate the effect? And this is an important thing to remember when you're working in some of the environments that Andrea was talking about, high energy, ocean environments. Do we even have the technology to really evaluate these effects? Okay, so those are our bins. Let's move on to our issues. And if you could move to the next slide. Thanks. So these are the 4 topic areas that we selected to work on. And in this case, we brought in specific expertise people to lead the discussions about sort of where we were with the state of science and address the known knowns, known unknowns, and unknown unknowns for each of these topic areas. So we had Chris Bassett to discuss acoustic impacts, Andrew Gill on EMF, Jocelyn Brown-Sarcino to do physical interactions, and Jesse Roberts and Craig Jones to do the physical environment. Next slide, please. The outcomes of each of these little topic panels is what I'm going to go through really quickly. And you'll see that a lot of our conclusions very much match up with where the State of the Science report is, which is really encouraging that we are going down the right path and coming to the same conclusions. So the operational noise or sound, again, this is a big report, so this is a very summary conclusion that we looked at. Both the question was, how much monitoring do we need to do for single scale or demonstration scale projects versus larger scale commercial or larger array deployments? And the sort of conclusion was that we do have some information collected, especially with wave energy devices. They seem to be less noisy than other sources of anthropogenic sound, and that for small scale arrays or single devices, that there's really very little need to do extensive monitoring. However, that by doing monitoring at the small scale, it'd be important then to do informed modeling that can be used to understand how a larger scale array could perform. So there is really still interest in doing monitoring on a smaller scale to apply it to understanding larger scales. And I think Andrea touched on this, the big issue being we still don't really understand what the behavioral impacts are of sound, and there's still a gap in information there. So that's still an area that we would want to do additional research, and is going on. Can we move to the next slide, please? This should be on EMF. So EMF, again, I think, again, this is from 2 years ago, and even since then there's been significant progress and knowledge gained on EMF. But at that time, we were able to say fairly definitively there had been no significant effects to organisms that had been observed either in the lab or in the field or in mesocosms. So that small-scale projects, EMF is generally not warranted because they're likely to be pretty low in intensity, again, EMF being proportional to the power generated by the devices. So, because EMF is relatively scalable, you can't really necessarily take what you learn on a small scale and apply it to a large-scale array or commercial project. But the good news is that there is information, or there is existing surrogates like subsea cables that are very high energy, high power transmission cables that you can use to do some of the monitoring or evaluation of what you might expect to see in a very large array. So again, the other good point about EMF is that modeling is another benefit. We're going to learn more and more, but they are modelable. So I think there's a lot to be gained by trying to put more emphasis on working towards understanding what a very large array how it would affect the environment. And then the next slide, please. This is what Andrea, I think, was calling collision, strike, or interaction. Again, in the lab, there have been really no interactions observed. Fish will move through turbines. That's been found in flume and lab settings. So they have very high survival rates. So at least on a small scale, single to small scale, there's no evidence really that there's been significant impact at all. The other thing to be very concerned about, and I think Andrea touched on this too, and the graphics at the bottom are the adaptable monitoring package that was being proposed to be placed at the open hydro turbine in Admiralty Inlet. These are probably pretty rare events. They're very difficult to detect. The types of equipment that you have to develop, them. They're not off the shelf. And you get a lot of data that probably has no information, which isn't necessarily bad. An answer of nothing is good. But it just means there's a lot of data, a lot of analysis of zeros. So I think the thing to keep in mind here is that this is going to be a really costly thing to evaluate, and that learning more by informing models that can help predict the potential impacts of strike either on individuals or populations is probably a good way to go, and certainly one that the wind industry has adopted. Can we move to the next slide, please? This should be the impact on physical systems. And in this case, I'm summarizing Jesse and Craig's work, but they have been doing numerical modeling, and their models predict that small scales will have very minimal, barely detectable, really, impacts on wave heights and flow patterns and sediment transport. So, for small scales, basically this is saying that monitoring is really not warranted because they're not expecting an impact. But larger commercial scale arrays, that is still not known, and so data are going to be needed, especially from large arrays, to be able to validate the predictive models. The next slide, please. So really the back and forth that we had in the discussion was that this collaborative type of interchange on understanding where research is and what we know and what we don't know, and hearing it from the experts, is a really good thing to help inform project permitting. So everybody thought it was a really good event to have and to communicate. We did discuss the idea that a collaborative type of organization to serve as a central clearinghouse would be useful for the industry. Again, just to keep everyone up on the state of the science and get everyone on the same page with where we think we need to focus the scarce dollars on to evaluate environmental effects. Again, the risky ones, as Andrea was saying. And then, again, keeping in mind that it's very costly to monitor in this environment, and variability is very high, and the events are likely to be pretty rare. So I think it's just something to keep in mind that we don't necessarily have all the instrumentation we would need, and even if we could afford to have it, it's going to be very difficult to detect these effects, and especially putting them towards understanding what the role is to populations. And there definitely is a need to try to incorporate modeling and simulation because of these events being pretty stochastic and pretty rare. So there's an avenue for a way to move forward. So taking those known unknowns and putting them into the known known bucket, if you will. Okay, so now I want to move on to the next slide, which is moving on to the workshop that was held at Oregon Wave Energy Trust meeting last fall in Portland, Oregon. So back to what we're doing with risk. We understand, everybody understands that we don't have very many devices in the water. We have a few, and we are monitoring them pretty intensively, but there's not a lot, there's no long-term post-installation data, and that is, part of the problem is we don't have a long database. So it continues to be obviously a concern and a worry because these risks are still out there, and it is, we just don't have the data to necessarily be 100% sure that these risks are retired. So there continues to be the need then to collect data, and these are very expensive data to collect, as we discussed, and some of these interactions are probably pretty stochastic. This provides or it puts on a very high financial burden for the industry, and it's clearly, like I say, there's a lot of the research that needs, a lot of work that needs to be done involves technology and monitoring methods that are not off the shelf. So it isn't really clear if all of our efforts are put in the right basket. In other words, are we focusing on putting all of our collection efforts at the highest risk interactions? And so, how do we track where we are in this risk profile, and how do we get to, if you will, decreasing that risk and bringing it down? So at the workshop, next slide please, we looked at the perceived risks of marine renewable energy development. And you've heard Andrea and I talk about all 6 of these already: collision, noise, EMF, physical changes, habitat changes, and entanglement. And we also added another slide for offshore wind, not to forget about wind. So let's move into these and our dashboards. Next slide, please. So the dashboards are basically, think about your car, a speed dial, and then some additional information to help inform how we could decrease the level. So we have the dashboard at the lower right, and that really kind of puts in a quick snapshot a way to gauge the level of uncertainty and risk about the interactions, kind of the green, yellow, red. It can also be updated as we gain more information, and it also just makes it really easy to kind of agree, or at least come to some agreement on whether we have a common understanding. So the actions then that could affect that level of risk or change the dashboards, we provide in a bar graph, and the 4 sort of actions trying to move the dial down to the green that we talk about are increasing the sharing of existing information. So it's information out there, but we haven't shared it well enough. Improving the modeling of these interactions. So can we model and make the models better? Do we need to have more monitoring data to verify our findings? Or is there really entirely new research needed? And so it kind of helps us focus on where the scarce dollars need to go. Next slide, please. We'll dive right into the dashboards. So for collision risk, really it's marine mammals, fish, and seabirds, as Andrea said, that are really of concern. There's high stakes there. A lot of them are species that are listed, special status species. And this really applies mostly to tidal and river turbines because, as we mentioned and I mentioned, that the instrumentation's very new and cutting edge and still not even entirely well vetted and tested for observing collisions. But from what we've learned to date is that there's little evidence of collision, and that the models, are definitely on the improvement side of things. But again, it's really focused on individuals. So the dashboard on this one, as you can see, is kind of yellow-orange leading towards red still. It's still a concern. There's still uncertainties, and that we need to do more and improve our understanding by doing more modeling, getting more monitoring data, and potentially more research, because the instrumentation to understand this interaction is still not, we're developing it. And then the next slide, please, we'll move to acoustics. So, as Andrea said, sound is could interrupt behaviors, especially for marine mammals. It does interact with other anthropogenic sources, so if a device is making sound, it's going to add to whatever the background noise is. So although we can measure it, we still don't really have an understanding of the reactions or the behavioral changes of the effects of the animals from the noise. Do they habituate? Do they avoid? Are they curious? We have no idea at this point, or very little understanding of that. So it's still a pretty high. The dashboard is in the yellow-orange, still a concern. And again, they're just the things that we need to really focus on. Well, we need more monitoring data for sure. We don't have great monitoring data. But things are improving. We are getting more sharing of information. Definitely, the behavioral scientists are learning a lot more about interactions of animals, at least with very loud noises. But that research is going to help inform us. But noise is still going to be one that on our dashboard is still fairly high. To move to the next interaction, which is EMF. And again, this is one where we feel like if you look at the dashboard, we're moving towards the green on, and it's because we are learning so much more in the last few years about studies that BOEM and DOE have funded about how animals are interacting, both in the field and then at PNNL, what they're doing in the lab. Again, the cables can be buried to separate the animals from EMF. So, there are fewer and fewer uncertainties with EMF, and we think we're getting down to the green. We're not there yet, but this is one where we're moving towards the green. And again, this is also an area where we think modeling is going to be really important in validating models. So this is one that we think in the near term we can start to really get that risk retired. And we move to the next slide. Changes in physical systems. And again, this one now, at least for small arrays, is very much in the green. The models are great here and have been really helpful in letting us understand sort of the interactions of small-scale arrays with changes to flow and so on. We probably still will have some needs as we move into commercial-scale size arrays. But this interaction is one that is becoming well understood and getting very close to being retired. Can we move to the next slide, please, then? Looking at the change in habitat and the artificial reef effect. Andrea talked about this as well. But this is just hard, basically, putting hard substrate in either on the bottom anchors, moorings, and then hard structure the devices themselves, and fish and animals congregating around them. And again, this is really one that is also well understood now by looking at surrogates and one way of understanding how animals interact with hard structure. And we know it's going to happen. We feel confident. There's still some concern about whether it's beneficial. And I think that's a question that some people would say, yes, it is. It's providing substrate for animals where it's lacking, and others would say the jury's still out. So I think here is where there's good information being learned, especially on surrogates, and we share that information. It's going to be important, but this is one where an interaction is fairly well understood and is coming down to the green as far as understanding the risk. Can we move to the next slide, please? And that's entanglement and debris, and this really addresses the interaction of animals with structure itself, not so much the interaction of the animals with the structure, but a secondary effect of the interaction of animals as they interact with debris or gear that is entangled with the device or its moorings. And so it is a big issue on the West Coast with whales repeatedly and fairly often turning up killed or injured by entangling with fishing gear. and that fishing gear could very much interact with the moorings and anchors of devices. So I think here, again, we're learning. There's a concerted effort to learn why marine mammals entangle in gear. I think that's going to help inform the potential for interaction with wave energy devices in particular. And then as we start to deploy, learning more about how gear may interact with the WECs and the moorings. But I think here it's really probably the biggest concern is the ecological, how animals entangle to begin with. And again, there's a lot of learning going on there for a different purpose that can be applied, I think, to the MRE industry. And the next slide. This is collision and avoidance, particularly seabirds and offshore wind. A lot of offshore wind, especially platforms, but structure that's underwater is going to be similar, if you will, to structure for wave energy. So, hard substrate in the water and those interactions. But this slide in particular is focusing on the above water potential for collision avoidance with seabirds. And on terrestrial wind, obviously we know that birds and bats interact and collide and get struck by turbines. So the same concern is true in the ocean with respect to seabirds and bats. And there's the potential for this strike to occur, but there's also potential for avoidance of projects that are in the migration pathway. So the issues for taking a wind project and moving it offshore really applies to how do you monitor this potential impact. And so improving the instrumentation for monitoring is a big push because you can't actually go out and do carcass fatality surveys in the ocean. So it's going to take a different type of monitoring for these interactions. And then there are models that we can adapt from terrestrial applications. The modeling in terrestrial applications is pretty mature, and it's just a matter now of applying those models to seabird ecology and offshore applications. So this one is still considered a fairly high impact and a fairly high risk because we are still on the learning curve in how to take what we've learned, I think, in terrestrial applications and apply it to the offshore situation. So let's move on to the next slide then. So at the workshop, Andrea mentioned that we had two panels. We had a regulator panel and an applicant or developer panel. And the regulator panel, sort of the high summary of this discussion was that we had walked away with a couple points. And that was that, standardizing data is important on the regulatory side so that they can improve the way that they do their analysis of effects on species and populations. So having data that is collected similarly and is provided similarly across the board would be an advantage. That they let us know would be good for the permitting process. The studies that allow us to work with developers to minimize the effects, potential environmental effects, are useful. So in other words, communicating that noise is a concern and is there a way to make devices less noisy? For example, EMF is a concern. Is there a way to make devices more shielded or less producing of EMF in the environment are things that we need to translate to developers, that these are concerns on the regulatory side and that there may be ways to work with developers to just sort of front load and minimize the outputs of these potential stressors. And then the third thing we walked away with, again, this is very high level, was that real-time monitoring was one area that the agencies really, really liked. And that was fairly useful for getting a very real-time understanding of impacts, and it could be very helpful in adaptive management and mitigation. So those are the three kind of high-level takeaways from the regulatory panel. Can we move to the next slide, please? Again, this is now the applicants panel, and again, high-level points that we walked away with is that you're always going to have uncertainty. So how much uncertainty is acceptable? Permitting does allow for some incidental take, some effects to be permitted, but how much? How much of that is okay, and how much uncertainty is okay? I think that that's a concern that industry has. Is you're never going to close the door on all effects. There's always a potential. So how do we get to where there's an understanding of what is permittable? How much uncertainty? How do we take information from other areas or other industries or surrogates and translate that then to helping to understand our uncertainty with MRE? And I think that's other side of a similar side of the uncertainty question is, we've learned a lot in other industries, and can we just apply that and try to green up or de-risk from what we've learned in other industries? And then another take-home that we learned was that there was a sense that there was inconsistent applications of the laws and regulations in different regions. And so it was a perspective that the industry brought, and I think in some of the applicants, industry developers, they had experience in various regions, and they were experiencing quite different regulatory environments. So that was another area that the applicants felt was problematic. Next slide, please. And I think this now, Andrea, I think you're picking this up.
Yeah, thanks so much, Sharon. Great overview of your workshop, but also what we did with at the OET workshop last fall. So what I want to do is to sort of bring these threads together and sort of thinking about the dashboards, and this really is something that Sharon and I dreamed up, and we're trying to kind of walk around. We spent some time with people at the workshop and since, seeing if this is a useful construct. We think that it's a good indication of the level of risk as we presently know it for each of those interactions. And interestingly enough, you can see the effect of investment in examining some of these interactions and how that is changing the dial. As a general rule, we still see collision risk as the highest problem for the tidal industry in terms of permitting. Acoustics effects are a problem still, or a challenge still, for both tidal and wave, and we do need to get at behavioral responses of animals. At the moment, we're in the U.S., we're seeing wave being challenged most by issues, uncertainties about noise and entanglement in mooring lines. Although we believe that EMF, we've greatly improved our understanding of this risk, and we hope it can be on its way to being retired. It's not there yet, and this is a wonderful example where there's been considerable investment by both the Department of Energy and the Bureau of Ocean Energy Management, and that has really helped, we believe, move that dial downwards. Next slide, please. So in terms of path forward with the dashboard specifically, we are looking for input. We really do want to know what you think from different perspectives, because we really hope these can become sort of a central point for starting discussions. And if we can all somewhat agree on this sort of set of more or less where we think the risk is, it will really help us to move forward as a community. We're just in the process of thinking through a way to review and update the dashboards. And although we developed these dashboards specifically with a Pacific Northwest focus, we believe they are very useful West Coast wide and actually nationally. There may need to be some more focus put on regionally as things change in different regions, but we do think there is a level of transferability, maybe even abroad. But there are still some issues remaining. And we are trying to think through some of the processes for getting at those remaining issues. Obviously, better, more very sort of research or hypothesis-driven monitoring data collection. We also think there may be a need for standardization. Now, this is a nasty word, and we're not using it in the way that it's used, for instance, technically. We are not advocating that everybody has to collect the same kind of data using the same instrument with exactly the same method. However, we are seeing data collected for certain interactions, and acoustic is a wonderful example, where there's all kinds of different types of data collected, which makes it very, very hard to bring them together and have any kind of comparability. So we would like to see a movement to try to at least determine what the major parameters to be collected would be. The next one is this idea of transferability. What can we do to ensure that data that are collected somewhere else, maybe it's Eastern Canada, maybe it's Scotland, could be usable in parts of the U.S.? Are there things that make these data sets comparable? For instance, using the same technology? Are there others where there must be considerable site-based data collection? It'd be really good to be able to really understand what those limits and criteria are. We continue to need to learn from other industries, probably most of all offshore wind in Europe. And we need to ensure that data sets, as they come in, are made available. We understand researchers and others want to use those data for their own purposes, but we really think this is a good time to share rather than keep things individual. So anyway, let's talk. We really are looking for discussion, input, disagreements, different ways to do this. This is our thought. And I wanted to let you know that there will be a follow-up workshop hosted by OET in September 2017, also in Portland, associated with their conference, as Jason mentioned. And our purpose here is to really have continued dialogue with regulators, project applicants, researchers, and so on. We want to provide updates on any major new information that's become available and really have some processes for moving this whole thing forward. Next slide, please. So this is just gives you a shot of the three major documents we've talked about here today. The State of the Science reports on the left there. And the citations are underneath. The one in the middle is the workshop report Sharon and I and colleagues wrote up from the OET workshop last fall. And the one on the right is the write-up of the workshop in 2015, the environmental risk for regulators. And those are all available on TETHIS. tethys.pnnl.gov if you're looking for them easily. Next slide, please. And that's it. I really want to thank you for your attention here today, and we are very interested in your comments and your questions. I'm going to hand it, I guess, back over to Jason.
I'll actually take the questions. I'll run this portion. This is Matt from Poet as well. If everyone sees there's a comment box. If you have any questions, please feel free to type them in there, but we'll go ahead and just get started with the first question that came in, and I'll just let Andrea and Sharon decide, or Jason, who would like to answer the question. So starting with Ken Dragoons, is there a relationship between the kind and number of animals and energetic environments? For example, are animals generally attracted to or avoid high energy areas in the marine environment?
I can take a first crack at that one, and then maybe Sharon will want to follow up. It's a really good question, and back to we know less about these areas of the ocean. Unfortunately, that really sort of hampers what we do know. However, there's been a lot of focus on trying to understand this in Europe. As they try to put, especially the UK, as they try to put devices in the water. We generally think of animals not going to these high energy areas, but we've seen some really notable exceptions, like with harbor seals in certain areas in the UK, where they are actually using these tidal races as sort of conveyor belts to go down one way to catch fish, and then they swim back up and go back down. But a related but not exactly the same issue, there's been some very recent results out of Wales, aren't published yet, but what we see is that harbor porpoise that are in the tidal area there leave the area once the tidal current gets up above 1 meter per second, which is, of course, pretty good news for tidal turbines, because many of them do not cut in till that speed, or could be made to not cut in till that speed. So these are the kinds of information we need to gather, but we don't know as much as we might. Sharon, do you want to add anything to that?
Yeah, I'll just mention that there has been limited monitoring, some monitoring information from tidal turbines now, and fish definitely are moving, in and out of areas when tides are running. But I always thought it was very interesting that some of the optical information was gathered at EMEC indicated that the fish basically weren't really showing up around the turbines until it was a pretty slack tide, and then they might come around and it looked like they were, to anthropomorphic, they looked kind of curious. But when the tide was running, there weren't much interaction or sign of fish interacting with the turbine. But then when it was kind of basically slack tides, the fish came around. So, there's not really, at least on the fish side of things, a lot of evidence that they're using the tidal currents to necessarily migrate or move through an area that they may hunker down. This is, again, in tidal situations, not talking about ocean currents, where we do know that a lot of species use ocean currents, but this is not the I think the question was about that. It was more about highly tidal current energy places. So.
Great, thanks. Just moving down the list here, we got about 20 minutes until we told you we'd be done. So if we want to keep the questions going, that'd be great. This next one's from Bill, who had to sign off, I believe, from the webinar here. But first, he asked about a recording of the presentation. Yes, we will be posting this to the Poet website, and I'll be sending out an email to everyone who is here today, and with a link to how to view that. But also following up with what efforts are being undertaken to inform regulators of these findings, and if they are underway, what kind of feedback are you getting from them?
I can tell you, this is Andrea, I can tell you what we're doing under Annex 4, and then maybe Matt or Jason can follow up there. Annex 4, the international process, has started a process of reaching out to regulators, starting in the U.S., and then we'll do that internationally. We did have a webinar towards the end of May that covered a lot of the same material in a little more depth, quite honestly, a little more, not assuming many of the audience, which included state regulators from around the country, may not have had as much background as this group does. We have been stood down for a short time by DOE on that, but we hope to take that up shortly and really determine what are the most pressing outreach needs for different groups of regulators, federal, state, regional, etc., and move forward with that. Do you want to add to that, Sharon or Jason, maybe?
Well, this is Jason.
Let me just add really quickly that obviously the OET regulatory workshops are going to be helpful for that outreach, and I know I'll let Jason talk about that more, but it seems like these documents, even just getting out and being available, is a big deal. Jason didn't have to encourage Andrea and I and others and our co-authors to write up the report, but I think just getting it to where it is available and we can put it in people's hands is a really good thing. But yeah, continuing this workshop series and getting more and more input and transfer of information is critical. So Jason, why don't you talk about that?
Well, certainly agree with everything you just said, and I think it's part of the challenge, right, to disseminate the information and to gain acceptance of the mechanism that we come up with, this dashboard. First, there's, I think, first of all, great value in having a standardized way of talking about these issues that's sort of simple, it's graphic, it's easy to understand. I think it would be wonderful if it gets adopted as a standardized way of talking about these issues. It's quite another question whether or not you can garner widespread acceptance for where the needle sits on the graph, right? Where is it? In which way is it headed, and how do we move it toward the green? The only way I know is continued pressure over time. I think there's no magic bullet here. You have to reach a lot of people, and you have to gain credibility. So the objectivity of the work, the level partnerships that we have with groups like H.T. Harvey and PNNL, the National Labs, the Department of Energy, the university system, et cetera, all of whom need to contribute to this information to provide that level of legitimacy and credibility. So from POET's perspective, I feel like about as much as we can do right now is to continue to support these webinars and focus on the dashboards. We'll host the second annual meeting on September 12th, the day before our Ocean Renewable Energy Conference in Portland. But in the long term, I feel like this is probably a 2 or 3 year effort. I feel like if we continue this for 3 years with concerted effort on identifying these issues and asking and answering the key questions, then we can be in a very good place in around 2020 when I think that we need to be in a better position to facilitate the deployment of the projects. I think we'll be seeing that that needs to speed up, and I think that based upon where the technology is today, 2020 is a pretty good target for being in a much better position for the regulatory community to understand these issues and get through the permitting process more quickly. So I'll stop there, and plenty of more to be discussed on that topic, but that's the focus right now.
Great, thanks. Next question, on a high level, at what point do you distinguish no impact from need better monitoring, especially for rare events like strikes?
Andrea here. I'll take the first kick at that. It's really difficult. We are, and a collision risk strike is a perfect example because we are sort of out to prove the negative, that it won't happen, which of course is not possible. So I think there's a lot of efforts underway to, yes, we need to be looking, have a turbine in the water and looking at it with optics and acoustics 24/7 for a period of time, but how long is that time? And we are going to have to continue to explore other pathways to sort of provide that assurance that these likely extremely rare events are extremely rare or non-existent. Just to take a little opportunity here, Annex 4 co-hosted a workshop in Europe last week where we looked at what we called management measures, which would be how would you deal with any of these perceived risks to lower those risks as we get towards these actual answers. And we looked at design features, we looked at installation, operation, decommissioning, and this work will be out in a few weeks, hopefully. And the hope is that we are not trying to do catastrophic things such as shut down turbines, but rather how can we really understand what that level of risk is and do some things that may help to lower it. Sharon?
I have nothing to add. Thanks.
It's one of those unanswerable questions at the moment, which is frustrating, but.
Great, thanks. Next question, Franklin. I'm not quite sure what you're referring to. If you could follow up, maybe we can be more specific and answer that for you. But the next question then would be, and Amy, maybe if you can scroll back to the slide that they're talking about here, but what are the percentages on the bar graphs refer to?
Andrea here, that's they don't actually refer to anything. It is very much, we should have said that, very much a relative scale. So it's really just trying to give you a sense that if the bar is filled all the way up, we think it's really a very high important priority. They are not quantitative. We maybe should take those off, but it's really trying to show you on a relative basis from interaction to interaction how important we feel this particular, more modeling or more monitoring research is. So.
Right, I agree. I sometimes regret that we put a percentage or a number on it because it really doesn't mean anything.
We'll work on that.
Thanks. And then another one, the wind energy graphic is not in the 2017 report, so is this added for the presentation?
Let you take that, Sharon.
Yes, we added that. We wanted to start thinking about offshore wind because it is now becoming more important on the West Coast. And so that's an area that probably we will include in the next regulatory workshop that we do, I'm assuming. Right, Andrea?
Oh, I think absolutely. This is a little bit of an artifact that the Department of Energy, that really is the biggest funder and driver behind these kinds of studies, divides wind and water. That's the only reason it happened. But we do feel, especially on the West Coast, we need to talk about wind as well.
Great, thanks. How might these dashboards gain first regional and then national attention and adoption as a standard way of talking about the state of the science and our understanding of the relationship between marine stressors and receptors?
Andrea here. I think the previous, where we all weighed in about outreach and reaching out to the regulators applies equally across the community. If this is going to be a useful construct, I think we have to get it out there. We have to get people talking about it, looking at it, criticizing it, changing it, whatever. So I think it's just things like this workshop. We did incorporate this into our first webinar with the regulatory community. I think getting it out there is the way to do that.
Yeah, and I'll just add that likely there's going to be some regionality to the dashboards. There will be some universals potentially, like EMF, but some of the interactions depend on the world, and it may be stronger or different depending on the animals that are present. So I think just getting them out there, thinking about that regionality, if it applies or not to the specific stressors, is going to be another step we'll need.
Excellent. What standardized databases are available, whether on TETHIS or elsewhere, for automating the synthesis of cumulative impacts across stressors and receptors?
Exactly the right question. It's Andrea, but we're not there yet. The data sets simply don't exist. I think at this, where we are at this end of the industry development, the important thing is making sure as they are generated that they are captured, quality assured, etc. And again, I've been working with colleagues in Europe. We have created a new little data portal piece on TETHIS that we haven't really launched or featured yet that will capture data as it comes in. I was just in Scotland last week, and we were hoping to see some of the early data out of the first tidal turbine array north of Scotland. There are no data yet, but we are looking to try to capture that. And again, that is our broad appeal to the industry as a whole and everyone else, that we really do make an effort to share data to make sure it's captured, it's good quality, etc. So hopefully 3-5 years from now we can answer that very differently.
Okay. Then this last question that we currently have, it's a bit of a discussion followed by a quick question at the end. So from the Canadian perspective, the quantification of risk in the environmental assessment side of project development is generally totally lacking when compared to the engineering design process. I think the environmental assessment side needs to do a better job of presenting risk in quantitative terms in order to highlight the relatively high uncertainty, levels of uncertainty. Interesting to see that you have put impacts on sediment processes as an issue of low uncertainty from the environmental perspective, while it is considered an issue of high uncertainty in the engineering world. Can we somehow put engineering risk and environmental risks on the same scale for comparison purposes?
Wow, it's a great observation and question. What's interesting is picking out the sediment processes particularly, and I think what's behind that is, and I assume this is someone probably working in the Bay of Fundy, the concern is sediment plumes could be of great sort of challenge to the technologies themselves, say a tidal turbine, etc. And those are natural sediment plumes. What we're talking about is in terms of really interrupting natural sediment processes on the environmental side. So I agree it would be great to be able to put them on the same basis, probably even before that. And I know I have worked on this, I know Sharon has, trying to work with the engineering side to ensure that they understand what our language is, what our issues are, what we are seeing as risks and why, and how those might be driven by or interact with specific technologies. I'm a huge proponent of trying to work with the engineers early and often to ensure that besides building the best machines possible and thinking about how would you do more effective maintenance, et cetera, how do we also build in ways to minimize environmental risk right up front? And I think from that, all of this can, this sort of relative risk look can grow.
Yeah, I will just add, for example, that perhaps developers and regulatory agencies don't want, for example, pinnipeds to haul out on devices. Nobody would want that. So, but I don't know that engineers are specifically thinking about that when they design their devices. So I think that cross communication is it's important, but there are definitely going to be, as Andrea pointed out, issues that are relatively important to the industry that are different, if you will, to the environmental regulatory side.
Yeah, I think that's absolutely right.
Thanks. So I think we're going to wrap things up now. We have a final comment that came in response to that, and we'll follow up with you, Susan, on that as well if you have any more questions. But before I pass it back over to Jason just to wrap this up, I do just want to thank Amy Woodbury and Jonathan Whiting as well from PNNL for their help in helping us put this webinar together and get it up and running. So thank you guys so much. And Jason, if you'd like to close us out.
Sure, Matt. Thank you. And thank you all very much for participating today. I think you can see why we're so excited to work with Andrea and Sharon. The work they've done to date already has been fantastic. And this presentation, I think, is a good example of that quality of work. So thank you both very much for your efforts on this. I encourage the participants to reach out to Sharon and to Andrea, to myself, to participate and ultimately contribute to this process. Really, only by widespread understanding and participation will we actually gain legitimacy and acceptance of this effort. So the next formal step on this is do the second annual workshop on September 12th in Portland. But in the future, I think we need to take the show on the road and do it regionally. And for those of you outside of Oregon, I hope that you'll continue to participate and talk to your associates about this effort, educate them on the importance of this. And I think over the course of the next few years, hopefully we can make some real progress on this and facilitate the introduction of new forms of renewables so that we can displace fossil fuel thermal resources and move us toward a carbon-free energy system as quickly as possible. So with that, thank you all very much. I hope you have a wonderful day and stay in touch. Thank you.